In this video, we are going to have a small discussion about how important it is for us to understand our models or designs. When we are working with simulations, we might be given a 3D model and all the fixtures and loads for us to set up. That would make it easier for us as we can directly set all that up in the simulation package. However, other times that might not be the case. Instead, we would need to figure out how to use the simulation to benefit us the most. In the later case, it becomes essential to understand how the model is being used in real life. This understanding is what will enable us to put together a sound simulation study. Let's take an example. Let's assume that we're looking to designing a workbench that will be used in a workshop. Now, we have to ask how exactly this workbench will be used to start putting scenarios or cases together. Here are some possibilities. The workbench can be used to place one big machine on top of it, so one big load. From there, the load can be at the center of the workbench. But also, someone can place it on the side of the workbench, so those are two cases. We have vices on the sides of the workbench. Other machines of certain weight can be placed at the very edge of the workbench. This is also a case that we need to consider. Yet another case can be with someone working at the workbench on a machine that is fixed on a vice. That person is applying extra loads on the machine that gets translated to the table or the workbench. And just like that, we already have 4 different cases for this workbench. Depending on where the bench is, we can probably get more cases out of it. Let's take another example of something more dynamic. And in this, we can look at a piston rod in a reciprocating air compressor. There are 2 strokes based on the movement of the piston, a suction stroke and a compression stroke. In many of the rotating equipment, we will always have repeating cycles, which makes it easy for us to make snapshots of those cycles to use for simulation. At 2 extreme cases of the whole cycle, there are 2 critical instances that can interest us more than others. At one end, the rod will get pure compression force. At the other, it will get a pure tensile force. We can call those critical cases. In between, the rod will get exposed to a variety of different loads. Now, I have 2 critical cases that I should simulate, but also I have other less critical cases that I can choose to simulate, but might not be as important. Now, the question would be, do you need to simulate all the cases? And the answer is, it depends on the scope of the study you are working in. If there are critical cases, then it will be important to simulate those. In addition to those, you can spend time and energy to simulate more cases if they can add to your understanding of the product at hand. There's no fixed right or wrong answer for this. Let's do some recap and conclude this discussion. When you are designing something, you must figure out all the cases and circumstances a specific part experience in terms of loads and fixtures. Then you can simulate each of those cases separately, paying particular attention to your critical cases, if any. Failing to identify critical load cases can lead you to designing a part that is destined to fail. That is something you don't want to do. Also, failing to understand the circumstances around your model means that your input or conditions you have in your simulation study might not be valid, and the result you get might be meaningless altogether. Human errors are common though, so it's normal to miss out on some cases. And this is why it's important to do real-life testing of your product if possible. This would be an extra precautionary step before investing in mass production.